Hi everyone, welcome to Confection Realm.
We are Group 11 for Dice Game, and we decided to make Confection Realm, which is a play on the childhood favorite Candyland.
I'm Michael Delaquila.
I'm Claire Salter.
And I'm Jesse Sandos.
Let's get started with gameplay.
So to start, we're going to have one player select player one, other player select player two, and both players press the start button. Then we're also going to select each player has their own profile. Player one is going to be Smarty, player two, Lolly.
For the gameplay, players are allowed to choose a dice setup to use each turn. Those dice setup values are listed in the Confection Realm rules, which pop up when you open the app and can remain open as long as the player wishes.
Let's get started by selecting the normal die and then hitting roll die on player one. We roll a 6 and it will play a dice roll sound as well as a pawn moving sound 6 times because we rolled a 6.
ThingSpeak is communicating data both about the last player who played and the last dice roll, so that player two's roll die button becomes enabled after player one becomes disabled, and the data of the roll they just rolled is updated to the table on both players.
As you can see, when the player presses the roll die button, their new position will be updated to the board as well as the other player's current position.
This is because the updating of the board is tied to a callback function on the roll die button.
Players must keep track of where their pieces are on the game board since there's a possibility of going backwards if they're not using the normal die.
Let's try that out.
If the player rolled a negative number, their dice value will be red, like in this example.
So for a five, which is a red die, you'll move back 5 squares.
And now you can see that the piece is populated on space number 7.
Let's progress through gameplay to see how this works.
The way that our code is written, your own pieces will automatically display as magenta, and the other player's pieces will be cyan.
For instance, on square 13 on both screens right now, one has a blue dot and one has a pink dot because one is that player's piece and one is the other player's piece.
It makes it a little bit hard to tell in the video which is which, but it is practical for gameplay use over 2 players.
Every time players land on a square, it's going to leave a piece of candy to show their path.
The number of pawn movement sounds that play is based on the absolute value of the player's roll.
One other element about the game board is that there are bridges represented by the rainbow sour strips, and these bridges are coded so that when a player lands on like the start of the bridge, it will move their piece to the end of the bridge.
As gameplay progresses, the player must make strategic options so that they can get closer to the 50th space on the board. Those strategic decisions can come in choosing these different die values to give them a chance to land on the bridges or just to progress faster than the other player.
For example, special die number 5 has a negative value, but it also has a higher weighting of larger positive values.
Additionally, if for example you're only 4 spaces away from the next Rainbow Road, you might want to choose Special Dice 2 because it has a lot of 4 options, or Special Dice 1 if you were 3 away from a Rainbow Road.
The game ends when one of the players reaches base 50 or beyond.
In our example, it looks like player 1 is almost there. Now the blue player has been able to cross the bridge.
I'm holding my breath to see if they're going to win this time. And we won!
So it looks like player Smarty has won, which causes the win screen to pop up, and also there to be a little audio playing.
To display the loser screen, the next player has to roll the die, but unfortunately, they were not able to be the first to reach the end of Candyland Realm. Now we're going to start looking through the code that goes behind Confection Realm. So this part of the code shows the start button, the app profile selector, and the player number. So this part of the code, when they press start, they are not allowed to press start again, and that is what toggles this on and off. Then they can choose their player number, which assigns them a player number to interact with the ThingSpeak. And in the profile button, we just used if-else statements to allow them to choose their player icon with a radio button.
So a key part of the Confection Realm gameplay is the rolling of the dice. So when you roll the dice, we have this audio sound that Claire uploaded, and we also have the rolled number being a random number generated like a normal dice, 1 through 6. But because we have special die, the way I coded that was that we're still going to have a random number 1 through 6 be generated, but then depending on what we get, depending on which dice we're using, that's going to yield a different value for the roll, so the number of places you're moving forward and backwards, and also a different image. So I generated which image is going to be based on these arrays that I created. So I made an image array for each special dice, and then the index of that is going to correlate with which dice is displayed. At the end of the roll dice function, it's going to call the functions we coded send data to other player as well as wait for other player. Send data to other player is going to communicate information about the player who just played the ThinkSpeak as well as the value of the last roll. So ThinkSpeak, when it reads it in the wait for other player function, is going to be able to know whether we are the player that just played or we're not. And if it's not, then it's going to enable the roll button again because we're done waiting for the other player. And it's also going to update our table with the value of the last player's roll.
After we roll the dice, we will send the data to ThinkSpeak, and then both players will sum up the columns of the table, with column 1 being for player 1 data and column 2 being for player 2 data. These values will then go into my score and other player's score. These totals from the table then go into a switch case statement, which determines where the player's pawns will be plotted, with my score going to magenta points and other score going to cyan points. When the my score or other score values are greater than or equal to 50, it will activate the win condition, which causes a win screen to appear, as well as clapping noises. On the other hand, if the other player gets to square 50 first, it will activate the lose condition, which has a lose screen and a lose audio. One limitation of our program is that when the other player gets to square 50, it doesn't automatically show up on the other person's screen. They have to hit the roll die button for that to initiate.
Compared to our proposal, we were able to implement basically all of the features that we wanted to. There were a couple of things that we just decided to omit for time-wise and because they didn't really make sense with the game. But as a whole, we're very happy with our final result. One limitation that we had was with the game pieces populating. There was no way for us to clear them without also clearing the image or putting the image back over the new scattered pieces. So that is one thing that we would want to work on in the future if we had more time. For the grading, we tried to comment our code as much as we could to explain what we were doing, and we tried to make the code as simple and streamlined as possible in terms of how many functions we had and how much data was getting sent to ThinkSpeak. So we decided to only send the player number and the score, since that would simplify the process. And then I worked on the audio and helping with some of the reach features, as well as helping code the ThinkSpeak. Jesse and I kind of collaborated on that. Michael worked on the dice game board, as well as all of the images for our game board and all of the characters. Jesse worked on the dice rolling and the functions for send data to other player and wait for other player. We worked together to compile the whole code. Please note that the game audio was too quiet to hear on our Zoom recording, but you will be able to hear it when you run the app yourself.